Hello and welcome to this video on logistic regression. My name is Kristen Kinsevich. I'm a PhD student at Regent University, and I'm using the textbook Using Multivariate Statistics by Barbara Tabachnick and Fidell. I have the 5th edition, so page numbers and tables will be referred to for the 5th edition, although the 6th edition can be similar in terms of table numbers. I'll try to specify that when I can. We are starting with this website, which is the companion website for the textbook. And you can see there they have the 6th edition. The data sets are the same. And you see here there are 2 logistic regression files. They're both referred to in the book. One is after we do some changing with the missing data. We're actually going to arrive at that by ourselves. So what you want, if you don't already have it from your professor, if you're working through the examples in the book, is this logreg.sav. So just the plain one is what we'll be working through. So I actually already have that open, and here we are. So the first thing that we're going to do is understand the data set. If you've looked at the other examples that I've walked through in previous videos, then you'll be somewhat familiar with this data set. We're still looking at women who are either working or they stay at home, and there's role-satisfied housewives or role-dissatisfied housewives. And so what we're going to do is try to use logistic regression to predict group membership in each of those 3 groups based on a variety of variables or predictors. So before we get too far into that, I wanted to just kind of give a brief little statement about what logistic regression is, because it is somewhat different than multiple regression, which is linear. Logistic is not a linear regression exactly, but it's really dealing with probability. And so on page 438, if you have the 5th edition, the authors say that the regression equation is the natural log of the probability of being in one group divided by the probability of being in the other group. And so essentially, what you end up with in logistic regression is being able to say that the odds of a certain thing being true are X number of times higher for this group than that group. And we will get there when we see our results. But, you hear this in statistics a lot, maybe, women are 6 times more likely to do X, Y, Z, whatever, as compared to men. Logistic regression gives you the kind of ability and data to say that. So let's clean up our data variables first. If you look at this, you can see right here that race is missing a label, which just makes your outputs uglier because it ends up defaulting to this the variable name when there's no label. So we'll just go ahead and put a label in. It can still be race, just kind of matching the format of the others. And now over here in the measure, it will make our lives so much easier if we have these correct. And so any that have these values here, where you see there's categories, these might be dichotomous, meaning there's only 2 choices. For example, race is white or non-white. Marital status is either single, married, or broken, so that's categorical. But it doesn't matter. All of those are nominal. The sub-no or the case sequence number doesn't matter, so you can ignore that. We won't touch that variable. But here, I'm just going to change these to nominal. It will make it easier visually when we're putting each variable in certain places. So I would recommend just making it easier for yourself now. All right, so we did that all the way up to race. Now here, locus of control is a scale, so I'm not sure why they have it as ordinal, but these are all scales, and also the year, age group. I don't know why they say group, because it's not really group, it's a continuous scale. And then years of schooling is also a continuous scale. So for the purposes of our how we're going to treat this data. These are correct. These scales are going to be placed in a different spot in the regression setup than these other variables here. So you can go ahead and just save that. And now the research question I mentioned already, we're going to be trying to predict which group, working, role-satisfied housewives or role-dissatisfied housewives, which group they would be in based on a variety of predictors. So some of these predictors are demographics, basically all of them except for the 4 attitude scales. So locus of control, attitudes towards marital status, attitudes towards the role of women, and attitude towards housework. Those 4 are the attitude scales that we've been using if you've done the previous examples. And the other ones, years of schooling, age group, socioeconomic level, and then all of these up here, race, religion, children, and marital status, those are all the demographics. So there's 7 demographic variables, and then there's 4 attitudinal variables. And so the question, the research question, is do the attitudinal variables significantly enhance prediction of group membership, working, role-satisfied, and role-dissatisfied housewives, after prediction by demographic variables? So this matches the second example in the book, which in the 5th edition begins on page 481. It's section 7.3. And we are using that second example because it is looking at 3 categories of outcomes. So the first example of logistic regression, there's only 2 categories that they could be predicted in. And in this second example, there are 3. So we will need to look at all of the parts of section 10.7, the complete examples, because a little bit of the assumptions testing is referenced in there. But for the most part, the results that we're going to be following are really starting in that second example. So they have, if you don't have the 5th edition, you can find this by looking for their first APA write-up, results write-up, and then this is sequential logistic regression with 3 categories of outcome is that next section. So basically, for our research question, we want to look at 2 things, and this is what makes it sequential. The first thing we want to look at is group membership prediction based only on the demographic variables. And then we're going to do a second step where we're going to look at all of the variables, both the demographic and then adding in the attitudinal variables. And we want to see if the attitudinal variables significantly enhance our ability to predict group membership. So hopefully all that makes sense. And the great news about logistic regression is that there's not a lot in the way of assumptions testing. This is much more straightforward than some of the other statistical analyses. So this should make a lot of sense. But the first thing that we need to do is look at the ratio of cases to variables and also evaluate missing data. And so what we can do first is what we've been familiar with doing. If you've gone through the other examples, we can just click on Analyze Descriptive Statistics and Frequencies. And let's choose all the variables except for case sequence. So you can just click on one, hold Shift down, and click on the bottom one, and then select them all at once. We don't need the frequency tables. Actually, I guess we might, because we're not doing charts. You're going to get a whole long output that we only need really the top 4. We don't need any of these statistics because we're really just looking at the count. What we want to just look for quickly is any missing data, just to get a sense of where it's missing, even though we'll actually do a broader assessment of missing values in a minute. I find it helpful to just look at it and see, okay, how much is missing where. That gave me a framework for understanding the next step. So I'm just going to click OK on this. I don't really want any data besides where is it missing. And so I can ignore all these frequency tables except this top one here, where I can see, okay, how many are missing. And so I see that religious affiliation has 3 that are missing. Locus of control has 1. Attitudes towards current marital status has 5. Socioeconomic level has 12. So I see here that there's quite a few cases. And in fact, there's a total of, I believe, 22 or 23. Let's see, 12. And that's 10 is 22, 23, and 26. So, but I believe the book said there's 22 cases. So some of these may be missing for the same person. So that gives us a sense, okay, we've got some missing data and we're going to have to figure out what to do with it. Do we ignore it and just leave it there? Do we replace some of the missing data with the means? That can be an acceptable idea. But we have to figure out if the data is missing randomly or not in order to be able to make that decision. So we don't want to just go deleting 22 cases. That's kind of a significant amount to just delete. So let's go over here and back to our data set. And there's actually in Analyze a missing value analysis, and the book refers to this. This is where you find it, and you just click on that. And now you can see we are going to select our nominal data here. Again, just hold Shift down and you can put them in a block. And down here we've got our categorical, oh, did that wrong. Totally backwards. Oh, sorry guys, I'm doing this completely wrong. Let me just move all this back and start over again. Okay, get rid of locus control. Let's select all of them, and these are the categorical ones, and these are in here in the quantitative variables. Okay, now in the descriptives, and this is described in the book. I'm trying to, let me see what page number this, I think this might be in the first example where they tell you about it. Section 10.7.1, and you see their output there. And so from the output, you can kind of tell which things they selected to be able to figure things out. And so here's what we're going to do. In descriptives, we actually don't need univariate statistics, so we can uncheck that. And we don't want the percent mismatch. So I think we don't want any of those things. So we can click continue. Then for patterns, what we want is the second option here, cases with missing values. But we don't need to put anything over in there for additional information. We just click that second one. Hold on, let me go back to here, descriptives. I'm reading my notes here. I think we actually do want the t-tests. And we want to change this to 1%. Again, this is just matching their syntax. So yeah, they have the t-test prob percent 1, and then they have the crosstab 1% as well. So we need to check off those. Okay, and then we want the EM estimation, and let's click on EM. Okay, I think that's all correct. Okay. Okay, yeah, I have EM normal, right? Okay, and here's this one I forgot. Save completed data. And so what you're going to do, and this is why they had 2 data sets for logistic regression, because we're actually going to create a new data set when we replace the missing values with the means. And so we can just call this edited logistic regression data set. And then we can run our analyses from there. Oh, write a new data file. That's what I did. Yep. Sorry. That's what you want to do, is call it that. So edited logistic regression data set. Okay, save. Okay, that will match their syntax. And so you should be able to just click OK, and hopefully we've done all of this right and my instructions are complete here. And we click OK. So now what we see is it shows us there were two variables that had more than 1% missing, this attitudes toward marital status and socioeconomic level. Not surprising, since up here in our first one, we saw attitudes towards current marital status was 5 and socioeconomic level was 12. So those were the most missing. So we see that down here. And it shows us a variety of t-tests here. And the thing we want to just notice is that whether or not our missing data is random. And so there is let me find it here. Can scroll all the way down. Okay, right here in this EM covariances or correlations, either one, it says the same thing. This bottom little line, it says Little's MCAR test, chi-square equals 38.257, 35 degrees of freedom, significance 0.324. So that means if there was significance here, that would mean that there's something non-random about the missing data, but because this is not significant, it means this is not significantly different from randomness. So essentially what that means, you can ignore everything else on this output and just write this up. They include this in their APA results write-up as well, but if you're writing out this as an assignment, this is the statistic that you want to cite. And so that proves that we can go ahead and replace the missing data with the estimated means because it seems to be occurring randomly. I'm going to go ahead and save my output, and I'll just do log reg output. Okay. So yeah, now the new data set, we can save this, but this still has the missing data. So we can go wherever you had saved your previous, your new data set, where we clicked the save as in the file. Here is mine, edited logistic regression data set is what I called it. And so now I can open it up and it should be, yep, here it is. This is the one. So I can close my other data set if I didn't already. Yeah, I'm going to close this one. Make sure you save it just in case you want to go back to it. But here now we have this, and what we can do just as another little test here is go back to our descriptives and frequencies, and we can select all of the variables again. And oh, that's interesting. So this one doesn't even have the case number anymore, which is fine. We don't need that. All right, so we can click OK, and here we see, now we can look at this missing data again. And there's zeros in everything now because the estimated means have replaced the missing values, except for religious affiliation, because that's a nominal one. There's no estimated means for that variable. So we just have 3 cases that are missing data for the religious affiliation. So we can go ahead and find those by going to the data view, clicking on religion, and you can right click and sort ascending. And here we see our zeros. These are our 3 missing cases. So there's a couple options that you have. You can either select cases and kind of cross those out. which would be a good idea if this was a real data set and you don't want to just delete cases and then not have them anymore. Though you do have your original data set, you'd have to go through the steps again. So for now, why don't we just go to select cases and click on if, and let's say if religious affiliation does not equal, or you could do is greater than 0. Continue. Okay. So now it's sorted our cases for us, and here you see, boom, 3 are crossed out, and so they will be removed from the analysis, and that leaves us with our N of 462. So now we've dealt with all of our missing data. Now we need to look at the adequacy of expected frequencies. And by the way, I think I forgot to say that we are following along with table 10.26, which is in the 5th edition on page 496. I think in the 6th edition, it might be table 26. It's just the checklist for sequential logistic regression with multiple outcomes. And so you see we're going through the issues list right now. We just dealt with our missing data, and now we're looking at the adequacy of expected frequencies. The ratio of cases to variables is really kind of just thinking, okay, how many cases do I have and how many variables do I have? And in this case, we have 462 cases and 11 variables, so that's a good ratio. If you had only 20 cases and 11 variables, that would probably not work. So you want to have a pretty big ratio. All right, so adequacy of expected frequencies. This is where we want to figure out kind of how many people might be placed in each category. So, you've got these variables with multiple levels, all the nominal ones, and you want to say, okay, of the working and role-satisfied housewives and dissatisfied housewives, how many of them are single? How many are married? And how many are in that broken category? And so crosstabs is a way for us to see kind of the expected frequencies, in which case we can tell when the regression comes along if there's going to be a whole bunch of variables that have zeros in certain categories. So let's say, especially the smaller categories like non-white women, there's a lot fewer of them in the sample. So non-white women from, who are single, let's say, and in fact, I think that is the one that ends up being the smallest. But, there might be only a couple cases in there. And so you want to look for anything that is going to have a value of under 5. Let's save our data set here and then look for this. What we're going to do is analyze and descriptives here. Then we're going to go to crosstabs. We have to run this a few times. Ultimately, we're looking just at the nominal variables. So these 5 here, and it's always a 2 by 2. So if we have 5 variables and we're comparing them each with each of the other ones, and there's 10 possible combinations. And so we can kind of do it in batches a little bit. So let's take work status, for example. We can do that one. And then we can do all these other 4. We can compare all these other 4 with work status. That'll give us 4 of our combinations. We don't need bar charts or anything like that. We really don't need statistics on anything. We just, we do, I think, we don't need the statistics. We need the cells. We want the observed and the expected, because the expected counts are what we're actually going to be looking at. So click continue on that. So this will give us our first 4 comparisons right here, and you see here's the crosstabs. So it tells you work status by current marital status. And we're going to be looking not at the actual count, but the expected count, because the logistic regression is going to be all about prediction, and expected count kind of gives us a sense of how many they would expect to be in those categories. And anything less than 5 is, we don't want a lot of variables, basically more than 20% of the cells, less than 5. So let's just look at these first 4 in the expected count here. Expected count here, this is close to 5, but it's still above 5, so we're okay. Let's look in the next one. expected. Okay, so that one's okay. Then looking here, those are all good. All these are plenty of wiggle room here. So that's great. Looking at the next one. Okay, this one's 7.1, but again, that's still fine. All right, so those so far, our first 4 are good. We'll save the output and do another comparison. So we'll go to Analyze, Descriptive, crosstabs again. Now we're getting rid of work status over here and we're putting it down below, and let's take marital status out of here and put it up here. So actually we don't need work status here because we already did the comparison of work status and marital status. So we really just need, this is going to give us 3 more comparisons, marital status and these other 3 it hasn't been compared to yet. Work status is out of the mix because it's been compared to everything so far. So our cells boxes will still be checked the same way we just did, so we don't need to do anything else with that. Click OK, and here we have 3 more comparisons. So now we have marital status with the presence of children. All right, here we've got a 5.5 again, but still that's above 5. Okay, so all those values are good. Let's look at this one here. Expected count is 5.1. Again, we're still, even if it's close, it's still above 5. This one's fine. Fine. Okay, marital status and race. And as I had mentioned, non-white single women, there's only an expected count of 2.7. So we have 1 under 5 so far, which is not a problem if there's only 1, but let's just keep going. So we saved that, and we got to do some more comparing now. Let's go back to our crosstabs. Let's take marital status out of it because we've already compared that to everything else. Let's do the presence of children now. Scoot it over there up into the top. Now we're comparing the presence of children with these other 2. So now we have 2 more comparisons. That'll bring us up to 9. Click OK. And here we are looking again, expected. Those are all good. And expected here. Those are all good. All right, so we have 9 comparisons. We needed 10, so we have 1 more to do. Analyze, descriptives, crosstabs, and we're getting rid of the presence of children now. Let's scoot race over here and up to the top. The last comparison we have is race by religious affiliation. And so we can click OK and just check that. So now these expected counts are fine. And so we're good. So that was your 10 crosstabs, and here in the output, you've got all 10 of these, and you can just, I like to screenshot and put them into my, summary of, I'm working through an assignment. So if you're doing that too, then you can just kind of crop these 1 or 2 at a time and paste them in. And so, yeah, that's where it starts. So you'll have 10 of these comparisons, and we only have the 1 case of single non-white women that's lower than 5. So that means that assumption is met, and we're good to go on that. All right, so now outliers is another assumptions question, and the nice thing is that this is not like outliers that we've had before, because logistic regression does not require normality of really the sample or normality of the distribution of scores or anything like that. So we're not going to go through and do the steps that we've done for other statistical analyses that involve kind of running a sample regression and getting the outlier charts and things like that. Really, if the only way we need to worry about this is if our model fit is not good. So we'll actually find this out later in the goodness of fit test. If that's a poor goodness of fit, then we might go back and look for outliers, but I'll tell you ahead of time, spoiler alert, we won't need to worry about it. So that's actually not a problem in here. And multicollinearity is also not a problem for this data because every variable is measuring something different, and they mention that there's no exceedingly large standards of error for parameters. So that's something that, again, you're going to find out kind of when you run the tests. If you had a unusually high standard error or something like that, then you might worry about that. So I'm actually realizing that I skipped that part in my own assignment, and I need to write a little statement about that. But on page 443, when it is describing it in the chapter, it talks about essentially multicollinearity is if there's high correlations among the predictor variables. And that, it says, would be signaled by exceedingly large standard errors for the perimeter estimates. And so that's what, when we see the output in the logistic regression, you'll see the parameter estimates, and that's what we'd look for. All right, so then the last assumption here is linearity in the logit, and that essentially is comparing, well, it's looking for correlations between the continuous variables and the logs of the continuous variables. So essentially we tested the nominal variables by making sure there was adequate counts. And here we need to do something with the continuous variables to make sure that they are going to work. And because the logistic regression is dealing with probability and logs, we want to make sure that there's not a continuous variable that is too highly correlated with its own log. So what we need to do is run kind of a fake regression, but in order to do this, we need to actually create some new variables, because we need to be able to kind of run the regression on the logs of the variables. So essentially what we need to do here is transform compute variable, and we need to create a log variable for all of these continuous variables here. So we're going to do, I'll call it L underscore, and then the same thing as the current variable name. And you're going to type in here LG10, because we're taking a log with a base of 10. And you're just going to click on that variable and close parentheses. So we're creating that variable. The new variable is L control, and it's the log of the control variable. And that's all we need to do. Just click OK. And then you'll see in your data set, if you look down here, here we have now a new variable, L control. So that's the log of control. We're going to do that same thing for all of them. So let's just, I find it easier to see the variable name completely first. So we did control. This one's called at mar. So that's the attitudes towards marital status, L at mar. I like them to match because then it's easier to look at. All right, so we're just going to keep going here, speed right through this. The next one is going to be at roll. Okay, and again. Socioeconomic level. At least this is fairly quick. Okay. Next one in the list here is attitudes towards housework. Oops, I'll see what I did there. I just thought in my own brain for a second. Trying to copy this here. Okay. That's right. Okay. And let's see, we should be getting almost done here. And see how our variables, by the way, are appearing right here, so we can see what we've done in case you forget where you're at. And now let's see, we just did housework, so age. Okay, and I think we just have one more, which is years of schooling. Last one. Okay, so we've got that done, and now we're good to go. Let's hit save on our output and save on our data set. Since we just created a whole bunch of new variables, I hate to do that again. Okay, so now what we're going to be able to do, again, linearity means kind of the line of correlation, right? So if something is nonlinear, then there would be an unusual type of relationship between the variable and the log of the variable. And so there would be just a question mark there, and we'd have to figure out why that would be. But linearity shows that there's a predictable relationship between them. So now what we're going to do is we're going to run a multinomial regression, which is going to be good practice for our main analysis, because that's what we're going to do. So analyze, regression, and multinomial. Binary would be if we only had two choices in our group that we were predicting, but because we have three choices, we're doing the multinomial, and that's the nom reg that you see in the syntax in the book. So we'll click on that, and here we want work status to be our dependent, and our reference category should be the first category. We're comparing everything against the working women. And now all the nominal things here are going to be the factors. And then the covariates are going to be all the scales and all the logs that we just created. So this one we don't want because this is our filter. It's not really a variable. It's just applying to our data set. So we can just either select the whole thing and eliminate that one, which I guess is what I'm going to do. You could do it in a couple batches here. Oh, I hit Control instead of Shift. I forget that sometimes. Okay, here we go. So we just need to make sure we take out the filter one here. That would be weird. Okay, so now I think that we can leave everything normal. The model is normal. Statistics. Let me see what we need. Let me look at their, I forget if there's anything specific. Let me look at their syntax on this part. Sorry for the pause here. Test of linearity and logic. Okay, so this is table 10.18, or maybe in the 6th edition it might be table 18. It's page 485 for the 5th edition. You see there, oh, okay, yep. All we need is the likelihood ratio test. I thought it was simplified. Okay, so yeah, we can unclick everything here. There's no need for this confusing output where we're not actually going to look at anything except for the likelihood ratio tests. So click continue, and criteria. Yeah, that's the same. Options. Yeah, we don't need any of that. Okay, so we're good. And so basically we click OK. And if you look at your syntax right here above, this nom-reg works at, it should pretty much match. There's some differences where we have this stepwise thing here that they don't have in their syntax, but it doesn't actually change the, actually, this might explain something here, because some of our significant levels are just slightly different from the book. And in their syntax, it just says model with nothing else. And so it's possible that because we did kind of a stepwise automatically here. So if you wanted to go back and do it again and click paste and delete that, you might get the exact same as the book, but it really ultimately doesn't matter because the smallest one is the same, and also they are generally the same, so they're very close, so there's not a whole lot of difference. So if you're happy, I'm happy, and we can just take a look at any that are significant. However, we don't want to just use 0.05 as our significance level, because here we'd see, oh, socioeconomic level would be a problem, or attitude role, but actually we have to have a different alpha level, which is 0.05 divided by 19, because that's the total numbers of degrees of freedom in this particular scenario, where we're actually counting up. I don't even know, I'd have to do this, let me see. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Oh, I know what they did. It's not degrees of freedom. That's right. It's the number of effects. So I believe if you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, and they counted the intercept as well. So it's 0.05 divided by 19. So the number of lines you have here, the number of effects, because you're basically doing one test with 19 different lines. And so you can divide 0.05 by 19, which is 0.003. And in this particular case, that's your significance level that you're looking for. Now here, all of these are above 0.003, except for race down here, which is 0.002, but that doesn't matter because that one is one of the nominal ones, so that's actually not measuring anything about the log. Right now, we're just really wanting to look at the comparison of the logs and the variables that are continuous. So here in this section, there are none. This one would be the lowest here, but it's still above the 0.003. I guess, sorry, this socioeconomic level would be the lowest, but still, oh, no, sorry, I'm right. At role is lower than socioeconomic, which, by the way, is interesting because those end up being the most significant in our mean analysis. Spoiler alert. Again, I'm really ruining this for you, aren't I? I am sorry. Okay, so now we are all set, basically, with this assumption of linearity in the logic, so we are good to go for our main analysis. I know you're all excited. I'm excited. All right, so here we have to first take a baseline prediction using only our demographic variables, because if you remember our research question, it was to compare, basically see if the attitudinal variables helped our prediction over the demographic variables. So obviously we have to look at the demographic variables first. So we are going to go back to analyze and regression, multinomial, logistic, and conveniently everything is kind of already in there, except we want to take out these log variables. That was just for our assumptions test, and they don't mean anything for us now. So we'll just scoot them out. Okay, so you've got your work status with reference first category, which is the working women. So we're going to compare the role satisfied housewives to the working women, and we're going to compare the role dissatisfied housewives to the working women. In a final test later on, we'll look at all three groups, but right now, just what we want to know basically is comparison of those housewives to the working women. And we've got our factors here, all the nominal variables, and our covariates are all the continuous ones. Now, we do need to check off some other things. The model is the same. We'll just do the same standard one. The statistics, though, now we need everything. So we need case processing summary, pseudo R-square, step summary, model fitting information. I don't think we need information criteria, cell probabilities, classification table, goodness of fit. Let me see what else they choose. Parameter estimates, do we have that somewhere? We're going to have to click on that somewhere else, I think. Step summary, classification table, model fitting info. Okay, yeah, so we don't need this or this. Yes, the parameter estimates we want. And the pseudo R-squared is going to be our effect size statistics, so that's going to help us. We don't need any of these. So If these are the boxes you have checked, then you are good to go and you match the syntax in the book. And oh, hello, sorry. I am not thinking here. Right now, we are only doing the demographic variables, right? So we need to get rid of the attitude ones. So over here in the covariates, get rid of those attitude variables. That's going to be our main analysis, which we'll do in a minute. But here we should have 3 covariates and 4 factors. That's your first comparison. And this is all in table 10.19, or maybe it's table 19 for the 6th edition. So yeah, in their syntax, actually, they only look at goodness of fit and classification, step summary, and model fitting info. They don't actually get the parameter estimates or the pseudo R-squared or things, but I felt like it was better to compare the whole thing to the second whole thing. And so I feel like for me, I wanted all of that. So I went back and redid it afterwards, but you can go ahead and do it if you want to follow the syntax of the book exactly, then you wouldn't have to check off all of those things. All right, so let's click OK. And there is this warning here, and that's going to happen when you have continuous variables, and it says, see, there's these with 0 frequencies, because it's looking at every single score of the continuous scale and seeing how many individual people were in it. You can see that, I think, down here. Where does it say that? Yeah. Yeah, and the observed and predicted frequencies. We must have still had that checked off. I don't remember getting that in my output. But anyway, I think ultimately we have what we need to look at, and you don't need to worry about the warning, is my point. So I was doing this, working on a different project, and I was getting that warning too. And I was actually kind of glad to see that my warning, that this assignment got a warning too, because that meant, I think, what I understood to be the case, that that's going to happen for continuous variables. If you were only using nominal variables, then you wouldn't have that problem, because your crosstabs would have eliminated that problem. If you would have noticed, certain small cell frequencies, you could have avoided that. All right, so here there's kind of some key things to look at that they compare in the book. They look at the goodness of fit, and so here we have, they reference the deviance criterion, which I think makes more sense. I don't really understand the Pearson one, and I'd have to look at that more clearly, but I would think a perfect fit would be a 1. You could look that up too. That's my understanding. So 0.872 is pretty good. That's a pretty good estimate. If you think probability wise, that's a pretty good fit. And here we are going to need to know this chi-square, 78.055. That shows significance there. This pseudo R-squared is the effect size, and they use this Nagel-Kirky one. I don't know if that's pronounced correctly, but 0.18, which, similar to other kinds of effect sizes, that's smallish to maybe approaching moderate. But it gives us a comparison. Ultimately, all of this only matters as we compare it to what's going to happen when we add in the attitudinal variables. So that's what we're really looking at. Our likelihood ratio tests we're going to compare. And notice here, and this is what I found interesting, that the book didn't mention, and I don't understand why, but when we're only looking at the demographics, the years of schooling is a significant variable, which when we run the main analysis, again, I'm ruining it all for you, but that's not going to be significant. So it was interesting to me that once we add in the attitudinal variables, that one's not going to be significant anymore. Current marital status is significant, and that will be significant in the last one. Again, I think we're, 0.01, that's not significant because we're still looking at 0.05 divided by, in this case, 1, 2, 3, 4, 5, 6, 7, 8. So you would have a lower threshold. So here are parameter estimates. Again, you can look at this once we do the other one and we can compare. So let's just do the other main analysis and then we can talk through some of it. I think that would be easier. Let's go to Analyze and Regression, Multinomial Logistic, and let's add in those attitudinal variables, which of course they're going to go down in the covariates section. Everything else is the same. We want the same exact statistics. Although, where was that? The observed and expected that we had checked off somewhere. I'm not sure where that was. We already looked at that. Okay. Let's just go ahead and click OK because it's going to be the exact same that we just ran, but we're just adding in the attitudinal variables. And so here we are. We still have that warning, which as far as I'm aware of, we can ignore. I'd be curious if anyone else finds out anything else about this. But like I said, in my other project, that happened too, only when I was using continuous variables. So now let's look at our chi-square here. This is 120, so that's a higher number. What we're going to end up doing is comparing that by subtracting the other one, which was, what, 78.005 or something like that. It's still significant here. And here, look at this 0.983. They call that excellent. So again, that makes me think that 1 is the perfect fit. And this 806.246 number they will reference as well when they're talking about that. That's the chi-square value they're talking about when they reference the goodness of fit. Here in our effect size, look at that. Our Nagel-Kirky effect size is 0.265, which again is not amazing, but it's moving it more into the moderate effect. And so we'll talk about that in a minute. Looking down here, we are looking for the significance in the likelihood ratio test. So which variables actually predict the most, help us predict the most clearly which working group they're in. Again, here, attitudes towards the role of women, we've got a 0.00. Years of schooling now is higher, so that one's not. And then we've got current marital status, 0.004, and race, 0.003. So I really went back and forth and kind of, it's a little bit dizzying to look at all of this in one output. I found it helpful to kind of take screenshots and be able to look from different angles. We could have, I suppose, if we had had hindsight, which I suppose I do since I've done this before, but I did it all in one output then too. We could make multiple outputs for each of the analyses, and that way, we could kind of do Alt-Tab and compare back and forth instead of scrolling up and down. And it's easy enough to run again. If you want to do that, then, start a new output. So let's talk through then a couple of things that they work through. And this is what you would write up if you're following along. And for my assignment, we have to go through 10.26 and talk about each of these things. So essentially the overall fit at each step, we really only have one step we're comparing to the baseline. So if you were doing this with, let's add in this and then let's add in these and let's do multiple comparisons, then you would have to talk about that. But in this case, we just kind of have one comparison that we're making, the attitudinal variables and how that differs from the just demographics only regression run. So that's what you're going to write about. So the overall fit, you can talk about the significance and the goodness of fit. That's where, and the model fitting information. So that's where I would kind of start talking about it, and that the goodness of fit is improved. They have an equation, and let me go back in order here. I felt like the order of the list and the order they worked through it in was a little confusing, and so it's put it in whatever order you want, I guess. But here on table 10.19, where it's the demographics only, they show you that model fitting information they show you the goodness of fit and the classification. Let me show you the classification on the first one that we did. Here, the overall percentage, so they were able to guess correctly 53.7% of the time. That's not amazing. And you can see here that they got 0 of the role dissatisfied housewives correct. So their guessing is skewed towards the working women. It's 81.6 here. Let's look at how that is in our final one. Okay, it went up a little bit, closer to 60% of the overall. But here they're still leaning towards the working women, but it did increase here. They got 11% of those correct for the role dissatisfied housewives. So that did improve things. This one I think was 35% or so. Now it's 50%. So that they're getting it better. This model, adding in the attitudinal variables, does help. So our research question, yes, is the answer to our research question ultimately, and you're proving it by writing up these various pieces. Now they have an equation on, where did they put that? It's page 492 for me in the 5th edition. It's the evaluating the improvement in the overall fit. And so what they do is chi-squared equals, and if you go up here to the model fitting information, okay, basically how well did we do? This is 120.273, and this one here was 78.055. So you just basically subtract, and our improvement was chi-square of 42.22 with the degrees of freedom 8, and that's because here we had 20, and in the next one we had 28. So there's 8 degrees of freedom difference, and the significance 0.000 minus 0.00, obviously P is still under 0.05, and so it is significant that there's a clear improvement in the overall model. So that's really the ultimate proof of our research question being correct and rejection of the null hypothesis. Let me see what else we need to compare. You can go through basically now, and this is where I felt like this was a very straightforward kind of analysis. They go through each of these comparisons, and they just, it's describing, I feel like the output is a little easier to read because it's kind of broken up into clear sections. So we talked about comparing the goodness of fit, the likelihood ratio, which, by the way, we're looking for 0.0045. It's 0.05 divided by 11. You have 11 variables in the main analysis, and there were the 3 significant ones. So you would anything under 0.0045. So race, current marital status, and attitude towards role of women. So those are the 3 that you want to note. And then you can describe the classification. And then the parameter estimates is kind of the next step on the list. And so there you could really kind of take a look at the differences. But here in the first parameter estimate, you can look and see, let's say for the significant one, okay, current marital status. They're looking at critical X value. For the main analysis, it's going to be 8.07, I'm sorry. The first one is 7.25. And let me show you where I found a calculator that got me this information. So the free critical chi-square value, this danielsoper.com, I've used him before in other videos. So if we go to if we have 7 predictors, it's 1 degree of freedom for the first analysis. Let me think. Oh, I wish I had written this down better because, that's what you need to do. Okay, so that's how it matters. you find the adjusted alpha level first. So 0.05 divided by 7 predictors is 0.0071. So that's our, that's our alpha level for the first output. Anything under 0.007 is going to be what we're going to look at. And then we have 1 degree of freedom. And so this is going to show us our critical chi-square value. We hit calculate. And here it's 7.25. I know this is right and it works because when I do it for the second test, it is what the book says as well. So basically, let's go to our output. And this is the first test we ran, right? Find the spot where it's the first one. All right, so we're looking for any walled statistic that is higher than 7.25. And it should be the ones that were significant. So here we have years of schooling, and we also have marital status 2, which means married. So this comparison is looking at the working women compared to the role satisfied housewives right here in this first one. So then, okay, we can see that this is above the critical chi-square value. When we go over here to this XB, this is ultimately the reverse log of the B coefficient. And what we see here, we see the significance. And this means that the role satisfied housewives in just the demographics only run, they are 7 times more likely to be married than the working women. That's what this tells you. How many times more likely is it? Or if it's negative, then it would be less likely. And then here we have years of schooling, and you can see, okay, it's not so drastic, but it's underneath. So the working women would have slightly higher education levels than the role satisfied housewives. And let's look down here and see what is significant or above that 7.25 value. Again, years of schooling. So the working women and the role dissatisfied housewives, similarly, the role dissatisfied housewives are still a little bit less likely to have the number of years of schooling that the working women do. And here, in terms of current marital status, there's nothing else that is above the 7.25 number. So that's the comparisons that are true for the first one. Let's compare that to the parameter estimates in the second one. Here we have a different one. So let's calculate our critical chi-square value. Now we still have 1 degree of freedom, but this time we have 11 predictors, and so that makes our value 0.05 divided by 11, and that's the 0.0045, I believe. Let's see if this comes out correctly, and then I'll know I'm remembering that right. Should be 8.07. Yes. Okay, so this is our critical chi-square value for the second test. And so let's look at our output and see which values are higher in the walled statistic. What's higher than 8.07? All right, here we've got attitudes towards the role of women, and we see that that's significant below 0.0045. We see here in the XB, it's really the exponent of it's taking the reverse log, right? So I believe it would be 10 to the 0.088 power. So the roles satisfied housewives are going to have slightly higher scores on the attitudes towards the role of women scale, which the higher scores indicate kind of more conservative thinking about the role of women in society. And so they have higher scores, not quite by a huge factor, but enough that there's a difference there. And then here, 10.761 is above our critical chi-square value. And here, wow, look at that. The role satisfied housewives are 6 times more likely to be married. That's a little bit smaller than in our previous comparison, but it's still pretty interesting. And then here, we look down here for higher than 8.07 and race. 1. That's white. So the role satisfied housewives are about 6 times more likely to be white than the working women. Now let's see down here in the role dissatisfied housewives if there's any values above 8.07. And the answer is no, there is not. So none of these variables really help us distinguish between the working women and the role dissatisfied housewives. And there's nothing that is significant below the 0.0045. So that's how we understand the parameter estimates. And now the effect size is, we talked about this already, we're looking at the pseudo R squared and this effect size here. And I did not get the same values as the book, and I don't know why, but the danielsoper.com website also has an R square confidence interval calculator. My only thought is that because this is R square and not pseudo R square, maybe that would make a difference. But if I go to I can do this 7 predictors for the first one, or I'll do the second one 11. My observed R square was 0.265. My sample size is 462. Calculate, and it gives me the confidence intervals of 0.197, or you could round that up to 0.20 and 0.33. That was different than what was in the book, but so I don't know how. I do know how they tell you that they use this program. I don't have access to that program, and so if you find a better way to do that, then let me know. I just reported my values and cited the calculator that I used. Okay, so that's the effect size, and you can describe that. And then the evaluation of improvement in the model is the one that specifically subtracts. So if you're writing this in order of the checklist, that's where you would put this model fit, 120 minus 78 from the first one, and subtract those degrees of freedom and report that significance just as they have in that equation in the book. That's where you would do that. So, we're basically done. The other thing you can do is look at additional analyses. So the odds ratios, again, we already talked about that. This exponent B, that is the odds ratio. So the odds of being married, if you're a role satisfied housewife, is 7 times more likely in this first one. And it was a little bit lower in the second one, is 6 times more likely once we added the attitudinal variables. You could talk about the classification table, which we already referenced here. It's not like you have to do anything else. You're just looking at other pieces of this output. So you could talk about the classification and the ways, the percentages here versus the percentages that we see at the bottom of our main analysis, and how it's slanted towards the working women, but it improves slightly in these categories. You could also interpret the means or percentages, which is what I did, and the book talked about that, so I'm gonna talk through that, and that'll be the last piece. And the other thing is evaluation of models without individual predictors. So you could take out some of the ones that weren't particularly significant and see what combination of predictors gives you the best classification rates. So you could play around with that. I'm not going to do that, but you could. So the last piece then is the interpretation of means or percentages. And so basically we're looking at, in our main analysis, which we decided, to include those attitudinal variables, so we don't have to report on the demographics only one, even though I was pointing out the differences there and the years of schooling and all that. The book probably left that out because that's not really the point of the research question. I found it interesting, but they're just looking kind of at the overall picture. Did it improve the prediction and the model fit? And it did. So they don't really care about the comparison of the parameter estimates. I just did. So what you want to talk about, though, is the significant differences on those 3 variables where the critical value was exceeded. So for attitudes towards the role of women, marital status, being married, and being white, you could make a chart, which actually I did, that shows the percentages of each group. So of the working women, how many are white? How many are married? And what is the mean on the attitudes towards the role of women? What's their mean score? And same for the role satisfied housewives and the role dissatisfied housewives, showing the percentages. How many of them are married? How many of them are white? And then what are their mean scores on the attitudes towards the role of women? So we actually, if we go all the way back to our frequencies tables that we ran away in the beginning, and our second frequency table is going to have our other ones removed, I think. Actually, no, because so you could look up here in the first one, the frequency table. First of all, this, well, that includes the 465, so that doesn't give you these won't give you the exact right numbers. We may have to, just for ease of not having to fly through our previous output, let's just do frequencies again. Oops, cancel. Analyze, descriptives, frequencies. And now let's just look at, get rid of all of these. Let's just look at the work status because we want to see how many women are in each group. We want to look at their current marital status because being married is one of the variables, and race was significant as well, and attitudes towards the role of women. So these are the things we want to see. And for the statistics, let's look at the mean, and we could maybe throw in the standard error of the mean or standard deviation even. Let's do that, standard deviation, because that's good to report. And charts. You could, if you wanted to do some bar charts, you could do that. Let's do that. Might as well. Let's do the percentage. Do that by percentages. Format. Okay. So statistics. Is there a? No. Yeah, it doesn't show the frequency. Okay. We'll see if this shows the observed frequencies or percentages or both. So let's click OK on that. And here, okay, yeah, so this is the 462. And so it shows us, here's the group sizes exactly for our sample, removing those 3. So you've got 245 working women, 135 role satisfied, and 82 role dissatisfied. And their current marital status, oh good, it does show you the percentages. So you can say, oh, this is of the total sample. Yeah, that's interesting. That's what I did. We have to compare the means, but this shows you the marital status for the whole sample. Well, that'll teach me to do something different than how I did it in the first place. All right, if we go to Analyze, Compare Means, and we look at the attitudes towards the role of women, and that's going to be our dependent list, and then the work status is our independent list. That will show us options. Yeah, okay, mean and standard deviation in a number of cases. Perfect. Now we could do the ANOVA table, but really these cell groups are different. There's differences in size of these groups, so we're not going to mess with that. We don't really need that. We're just going to click OK, and this is going to show us the mean for this scale. So this would be what you would put in your chart. And again, here gives us our group sizes, so we have that. This shows the standard deviations. So you can see that the role satisfied housewives have the highest score, and the working women have the lowest score. So that's where the difference lies in their attitudes towards the role of women. That was a significant variable. I am pretty sure that up here, how did I get that before? I had some way that I got that. The other way you can do it is to split the file into the work status groups and organize the output by groups there. and then go back and do your analyze descriptives, frequencies. Now we don't need this one here because we don't need this because it's splitting it up already. Now we just want to know the marital status and race. And what do we want? We don't want the mean or standard deviation because these are nominal variables. So it's just going to show us the frequencies, and we can divide them to get percentages if it doesn't give it to us. So we'll click OK, and here it should sort it now so that we see, yeah, so for the working women, 168 of them out of 245, which, yeah, it does tell us the percentages. So 69% of them were married, and 89% of them were white. And here's a beautiful bar chart if you want. That's for the working women. And then let's compare that to the role satisfied housewives. 94% were married, as opposed to the previous one, 69%. So you see there's the difference right there, 69 versus 94%. And in terms of being white, 97% of these are white, and the other one I think was 89%. And then you also have the role dissatisfied housewives, which I made a chart that included all three, just because then you do get the comparison of the role satisfied and role dissatisfied. And in this case, 78% of the role dissatisfied housewives were married. And again, 89% were white. So you could basically make a chart with those three groups and those three variables and just plug in the percentages. And when you report the means on the attitude towards the role of women, I would include underneath it the standard deviations. So just save your output and save your data set here. It's sorted differently, is why there's only one slash right here now, because we had filtered it by the working groups. But we're done for now. We don't need that anymore. And so that's it. I feel like logistic regression is a really simple kind of idea. I'm sure there's still things I don't understand about it, and I am applying this to my final project for my class, so I need to keep exploring it. But I really like it as a concept, and I think it makes sense to even just how marketing and things run in our society. You think of, how many times more likely is this group than that group to do something, or can we predict which group this person be in? When you think about counseling or psychological studies, even health studies, you're looking at risk factors and what factors would contribute to them being in a well group versus an unwell group, something like that. So there's a lot of applications for this, and because it can use a combination of dichotomous and or categorical and continuous variables, it's kind of flexible and it doesn't have as many assumptions. So anyway, I don't know why I'm plugging logistic regression, but if you've made it all the way through this video, thanks for watching. And you can subscribe to my YouTube channel if you like these videos, and then you'll get notification when I make more that might be similar to it. So thanks a lot, and I will see you next time.